Hi CTO Minutes, welcome back to the channel. Today I want to do a deep dive into Zolution. Zolution, 0-degree overlap, universal 3-dimensional wiring. First, I want to talk about how I came to this concept of 0-degree overlap. And it comes really from adapt wiring. You can say there's an evolution from adapt wiring towards Zolution wiring. In adapt wiring, you remember, we have to turn the wire tip very small degrees, 14 degrees, 27 degrees, 37 degrees, or 44 degrees, dependent upon the near view divided by the far view ratio. This 2 ratio actually corresponds to the opposite and the adjacent of a right angle triangle, and the degree that you have to turn by this ratio is expressed by the term tangent theta. So here I am figuring out how I can turn a wire with a torque 14 degrees, which is about 2 minutes on the clock face. And I'm even thinking about designing a torque with markers so you can turn and know how far you've turned. And then suddenly it occurred to me, duh, I'm really dumb. Why did I not think of this more elegant solution? Here I am working so hard to turn this tiny little wire tip, tiny degrees of 14 degrees, when instead I could turn that huge X-ray machine 14 degrees. And the X-ray machine has degree markers, so I can turn precisely 14 degrees. Do you understand? If I turn the wire 14 degrees so that it points directly to target, I can also alternatively turn the X-ray machine 14 degrees and straighten the wire tip, and that will be far more accurate. Now, the reason why my brain refused to adopt that idea, the sort of halting of the evolution process, was because I realized immediately that if I were to do this, there will be many segments of the coronary artery that your X-ray tube will not be able to go a further 14 or 27 or 37 degrees. So let's say you are doing proximal RCA, CTO, and you're in LAO cranial 45, caudal 45. And you're near, and your 2 views, you have a near view and a far view, and they're both on the same side of your target. This means you got to go further cranial or further caudal, or to the side that's the near side, in order to get that overlap view. And you won't be able to do it because pretty much 45 cranial and caudal is as far as you can go in the LAO view. So my mind sort of rejected this idea of using the X-ray tube rather than the wire tip to make these very small angles. Now, so that in fact actually highlights one of the limitations of Zolution wiring. And that is, if your X-ray tube can go 180 degrees around the target, then you'll always be able to find the 0-degree overlap view. However, if your X-ray tube can only go 90 degrees, around a target, like in the proximal RCA, distal RCA, or the left main proximal LAD, then you can only get the 0-degree overlap view in 50% of the cases. 50% chance your wire will be in the first quadrant and the last quadrant. And if your wire is in the lateral 2 quadrants of your X-ray tube direction, you're not going to be get an overlap view. And this was the limitation that prevented my brain from adopting the idea of moving the X-ray tube instead of moving the wire tip. Now, what this means is in mid-RCA and in mid and distal LAD, where you're using LAO and RAO view, you can go 180 degrees, which means in these coronary segments, you can always find the 0-degree overlap view without fail, 100%. In proximal RCA, distal RCA, proximal LAD, and left main, because it's horizontal and you're dependent on cranial caudal, and you can only do around 90 degrees cranial caudal. 45 cranial, 45 caudal is about as far as you can go. This means you can only get the overlap view in 50% of wire positions. Okay? In the circumflex, it's even worse, because if you're going areocaudal and iliocranial for a diagonal vessel, you can only get about 60 degrees difference between the two views, which means you can only capture the overlap view in about 33% of the cases. So this is a problem. Now, it is not a very big problem because, or you can say it's a limitation. It's not a very big limitation because most of the CTOs are in the LAD and the RCA. Those of you who do CTO will know this. LAD and RCA CTOs are far more common than circumflex CTOs. So most of the time you have, and also you're traversing in the LAD two segments that you can definitely see, in the RCA, the mid-RCA segment that you can definitely see. So if you calculate if CTO occurs equally in all three segments of proximal, mid, and distal of LAD and RCA, then in the LAD, roughly 85% of segments, you will be able to, 85% of the time, you will be able to see the overlap view. And in the RCA, by the fact that there are two segments that are 50%, you'll be able to see 66% of the time. So this is, of course, less than the 100% of the time that you'll be able to do it if you were using adapt wiring or Okamura method, okay? So it is less. In the circumflex, of course, you'll be able to see 33% of the time, the overlap view, but in the Okamura or the adapt wiring, that goes up to 66%, okay? So there's that limitation. And the point where I suddenly decide to evolve entirely into solution wiring is when I realized there's a very neat solution to solve the problem of not being able to get the 0-degree overlap view. And the solution is to move the wire, okay? So imagine you have this pie and you have 4 quadrants in an X shape, okay? And your X-ray tube is right from the top. If you're in the 2 lateral quadrants, the wire position in the lateral quadrants, you won't be able to get an overlap view. But if you pull the wire back and you turn it around and wire through another quadrant, wire to a different quadrant, you'll be able to get the overlap view. So if you can't get the overlap view, you can just turn the wire to a different quadrant and you will be able to get the overlap view. Now, this might sound very tedious. I mean, you say to me, oh, CTO demon, every time I wire 1 millimeter or 2 millimeter forward, I have to do this again. I have to put the wire to another place, and then I'm going to lose my wire position. And you never wire a CTO that way. That's not true. Because once you put yourself into a quadrant that you can see on your current available angiographic views, you can actually keep that wire in that quadrant. You don't let that wire go out of the quadrant. And how do you do that? You do that by minimizing the angle you use for your secondary view. Okay, walk with me here. This is your X shape, okay? Quadrants, your X-ray is coming from top to bottom, okay? Let's say you're outside and you can't get, through your 90 degree, you can't get an overlap view. You rewire the wire and it comes in slightly near this line of the X at the top, okay? And now you look at it and you go quite near to the end of your LAO, let's say, and you can get an overlap view, okay? You straighten the wire tip. What you do is you do not go to the other 90 degree view, but less, you go, let's say 45 degrees, okay? What this means, the difference between 45 and 90 is on 90 degrees, you will be further from the target. At 45, your wire will be nearer to the target, simply from the angle. If you push until you overlap at 45, okay, this 45 view would then be the overlap view, and you straighten the wire there, which means you'll be staying within a quadrant. Now, if you go 90 degrees and you push till there, you'll be at the very edge of it, and you have a danger of dropping out of that quadrant. So if you limit the angle that you change, and because you don't need 90 degrees for solution wiring, if you limit your angle of your secondary view, you can actually keep the wire constantly inside your quadrant. So you only need to reposition the wire once for wiring a CTO segment, until of course the vessel course changes entirely to a different direction. Then you have to start again. But so it's not as bad as it seems, this repositioning of the wire. So with this repositioning, actually, you can, in the horizontal segments, proximal RCA, distal RCA, left main proximal LAD, because you have 90 degrees, if you reposition it once, you can actually double your success rate, which means almost 100% of these segments, you can get a 0 degree overlap view. In the circumflex, if you reposition it once, you double your success rate, again, from 33 to 66%. Now, this actually compares favorably with Okumura and with adapt wiring, because in both those techniques, due to the limitation of 60 degrees in the circumflex territory usually, their ability to do 3D wiring accurately is only around 60% as well. So you're not losing out. So with this solution of repositioning the wire, we can actually get solution wiring up to the same level of accuracy in terms of being able to see it in coronary segments as traditional full mental or Okumura or adapt wiring. Now, one last point in this deep dive into solution wiring is that if you think about it, the tangent theta theory from the adapt wiring can actually help us determine the 0 degree overlap view. Okay, so we said that you find the view by moving it. If the two views that you have at the moment, the wires are on the opposite side of the target, then the true overlap view is in between them. Okay, and if the two views you have at the moment, both wires are on the same side of the target, then you need to move the tube towards the one that's nearer side to get the overlap view. But you can make it more precise. Using the same adapt wiring mathematics, tangent theta is opposite over adjacent. You can tell that if your wires are on the opposite side, if you divide the nearer wire distance to the target from the further wire distance from the target and put it into ratio, if it is 1/4, you need to move the tube towards the middle between the two views 14 degrees from the nearer wire side. Okay? And it will be 37 degrees from the further wire side. Okay? And similarly, if both your wires are on one side of the target and you made a division, and let's say the near wire is half the distance of the far wire, then you need to rotate the X-ray tube towards the direction of the near wire side, and you need to rotate it 27 degrees because tangent theta is 27 degrees. So actually, if you understand adapt wiring, you don't need to do so much guessing and finding of the 0 degree overlap view, because you can work it out mathematically. I'm not suggesting you do this. This is quite a lot of effort, okay? But if you're familiar with this and you want to think a bit more, then you can quite quickly find the 0 degree overlap view simply by doing this. And also, this will mathematically tell you whether you're still within the range your fluoroscopy can go for your particular segment. And if you're not, then you just go straight to repositioning the wire. So this is kind of a deep dive into the limitations of solution wiring, also telling you how I evolved from adapt wiring to solution wiring. And of course, giving you some hints as to how to find the 0 degree overlap view the most efficiently using the mathematics behind adapt wiring. So I hope that this deep dive will help you understand more of the sort of deeper mechanics and mathematics behind the solution wiring. But it doesn't matter if you don't get it, because it doesn't alter from that very simple 4-step way that solution wires can work most of the time. I guess the takeaway from this practically is, if you can't find the 0 overlap view, just reposition your wire to another place and you'll be able to find it. That's the simple answer. So I hope that this is helpful to you and that you understand more about it. I will try to do more deep dives into solution wiring as I get along the stage. And I hope that you keep following it. And if you like these deep dive videos, give me a comment and subscribe to the channel. We'll see you next time. Bye-bye.